Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! Okay, so we're going to start by writing this out a little bit bigger, give us a bit more space. So it's minus 6x is less than 60. And we're going to do our tram lines down. And we're going to start by dividing both sides by minus 6. Because that's what this is doing, it's timesing the x by minus 6. So I'm going to divide both sides by minus 6. So that gets rid of the minus 6 on the left hand side. And it's going to be 60 divided by minus 6, which will be minus 10. Now we've got to be really careful here, because whenever you times or divide both sides by a negative, you must switch the inequality. So instead of pointing to the left, it's now going to point to the right. So our answer is x is greater than minus 10. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down. But here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour, because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one. And the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got two of the three angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. So for this frequency polygon, what we've got to do is work backwards to work out what the table was that created it. So we're going to just draw a starting of a table, and we're going to have our midpoint first, then our like money spent, our intervals, and then our frequency. So the first midpoint is at 40, and we can see here that that was, just get rid of that, that was between, like that was in this group here. So that is 0, and I'm just going to use M for money, 0 to 80, and the frequency is how high it is, which is 10. The next midpoint is here, so that was going to be 120. And we can see that that's between 80 and 160, and the frequency is 20. And finally, the last midpoint is here, which is obviously 200, and that is between 160 and 240, and the height of it is going to be 7. So we're looking for the probability customer spent less than 160. So that is these two here. Okay, so there are 30 that are less than 160. And how many are there altogether? Well, it's that 10 plus the 20 plus the 7. So it's going to be over 37. So it's 30 over 37. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31 and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals -2x minus 1. And we're told that the y is -37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be -36 equals -2x. I'm going to now times, or divide everything by -2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18 and the x value is the w value. So w is 18. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him, or her, 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power 16 times 9 to the power 46. Now, when you have 2 powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62. So it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between 2 powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40. We just take away the indices. So it'd be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next I'm looking at the t terms. We've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally I'm going to look at the u, and there's just a u on both of them. I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So Pythagoras says that a squared plus b squared equals c squared, and the c is the one opposite the right angle. So I'm going to label this a and b, so it would be 5 squared plus 12 squared equals c squared, 25 plus 144 is equal to c squared, and then 25 plus 144 is 169. And then we're solving to find out what c is. And we're just going to square root both sides. So square root of 169 is 13. So c is 13. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us, what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 meter and the 35 meter. And essentially what this question's asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6. And so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So here we're asked to factorise a quadratic, and our answer will be x plus or minus something, x plus or minus something. So it'll be 2 sets of brackets with an x at the start. Okay, so to be able to find out what's in the bracket, we look at the 36 there, and we know that we're going to have to multiply 2 numbers together to make that 36. And we look at the coefficient of the x, that 15, and we know we're going to have to add these numbers together to make that 15. Now, if you just can figure out in your head the answer, that's absolutely fine. If not, you can just quickly write down the factors of 36. Now, because they multiply together to make a positive 36, they'll either both be positive or both be negative, but they add together to make a positive number. So we're just looking at the positive factors. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And we're looking for which ones of those add together to make 15. And we can see here it's going to be 3 and 12 add together to make 15. So our 2 numbers are going to be plus 3 and plus 12, or the other way around. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom 2 angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom 2 angles are equal. So they're the bottom 2 angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees, and this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100 because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08. And as a fraction, we can just times top and bottom by 100. So it would be this over 8. So now we can do the bus stop method. So 8 on the outside. And in fact, I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now it says how many bread rolls can we make. Now we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. To draw a quadratic graph, we want to find as many values as we can. Because it's a curve, with a straight line graph you only need 3 points. With a curve you need as many as you can get. And now we're actually given a table here to fill out, and so I'm going to start off with a 0 here, and here we want to substitute in the x equals 0 into our equation. So we've got y equals x squared plus 11, so it's y equals 0 squared plus 11. 0 squared is just 0, plus 11 is going to be 11. We're going to do the same for 1, so y equals 1 squared plus 11. 1 squared is just 1, 1 plus 11 is 12. Same again for 2, 2 squared plus 11. 2 squared is 4, 4 plus 11 is 15. Now the minuses are a little bit more difficult, but not that much difficult, because when you square a negative you actually get a positive. So minus 1 squared is just 1, 1 plus 11 is 12. And then minus 2 squared plus 11, minus 2 squared is 4, 4 plus 11 is just 15. Now you can see here we get a nice little symmetry, and we're going to plot this onto our graph here. So 11 is going to be here, 12 is going to be here, so both of these are 12, and 15 is going to be here. Now when you join them up, what you want to do is avoid having a V. Okay, in the mark scheme specifically it says that the bottom needs to be nice and smooth, and avoid something called feathering where it looks like that. You just want one smooth line. Now the best way I find of doing it is turn the page sideways, which I can't do with mine, but you can turn your page sideways and just one smooth line, and we're going to do a nice smooth bottom there. And I just need to lift, try not to lift with yours, and that should be good enough for full marks. Let's just try it again, just have a bit more of a lift like that. That's also good, and I can do this all day. Like the ones that are bad are the ones with gaps, or the ones where they miss points. So if you had yours like this where it just missed that point out or something like that, that would not give you the mark. You just want one nice smooth, just slip there a little bit, nice smooth, and that probably wouldn't, because you can see that I've kind of hesitated there. So it just takes practice, and as I said, if you turn the page sideways, it's a lot easier to draw a C than a U. So to answer this question, we've got to first of all work out what transformation it's going to be. And it hasn't changed size, it has changed its way up, and it's obviously going to have been rotated. There's going to be a rotation. And for a rotation, we need to know the angle which it's rotated and where the center of rotation is. Well, it's obviously gone 90 degrees, it's gone a quarter turn, so it's 90 degrees, and it's gone that way, and so that's the same way as a clock goes, so that's a clockwise. And we need to find the center of rotation, so we need to find out where the center of the rotation is. So the way of doing that is just trace out the shape you've got. So trace out A. And it's going to look something like this. And trace it out. Just connect those bottom bits a little bit better. And trace it out. And what you've got to do is you've got to find out where on this page you put your pencil when you rotate it. And so you're just going to rotate it with putting your pencil somewhere. So you want to end up with it looking like this on the tracing paper. And you, just with a bit of trial and error, you'll realize that you can put your pencil here. So your pencil will go at 2, 2 to get from A to B. So our center of rotation is going to be 2, 2. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. Two negatives make a positive, and 12 times 12 is 144. A different way of writing this is 1 plus 1/3 plus 2 plus 3/8. So what we can do is just add the 1 and the 2 together to make 3. And then all we need to do then is find out what 1/3 plus 3/8 is. So we're looking for a common denominator between those two. And 3 and 8, if you write out the 3 and the 8 times table, the common denominator is 24, which is 3 times 8. So we're going to times top and bottom of the third by 8. So it becomes 8 over 24. And top and bottom of the 3 over 8 by 3. So that's 9 over 24. Add the tops when the bottoms are the same, so that would be 17 over 24. And then that would just make the answer 3 and 17 over 24. The way I remember what to do here is using KFC. And what the K stands for is we're going to keep that fraction exactly the same, so 2/3. We're going to change, that's what the C stands for, change that divide to a times. And we're going to flip, that's what the F stands for, the 8 over 7, so it becomes 7 over 8. Then all we need to do now is multiply the tops, multiply the bottoms, and simplify if possible, so we can actually divide top and bottom by 2 here. And it becomes the answer, which is 7 over 12. The key to estimating is that normally you will be rounding numbers to one significant figure and then working out the answer. So I'm just going to rewrite this fraction here. But instead of 93, we're going to round that to one significant figure. So that will be 90. We're going to round the 265 to one significant figure. Now, some people will write 270. But one significant figure means the line goes after the 2, and so that would round to 300. Then 31 will round to 30, and 97 will round to 100. Now the next step is to see things that we can cancel here. So we can divide top and bottom by 10 to make that a 9 and make that a 3. We can divide top and bottom by 100, make that a 3, make that 1. And we can divide top and bottom by 3, so that will make that 1, and that will make that 1. And so at the top we've got 9 times 1, which is 9, and at the bottom we've got 1 times 1, so 9 divided by 1 is just 9, So our answer will be 9. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it would be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So the first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So the first thing I want is I want the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals minus 7. Okay, so what we do now is we put both our equations down so we can solve these simultaneously. So 5x minus 4y equals minus 7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we want to get rid of that. And 47 take away 7 is 40. All right, let's put our solving lines in. And we're going to divide by 8 both sides. So we get x equals 5. And we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47. And then we're going to take away the 15 both sides. So it's 4y equals 47 take away 15, which is 32. Divide by 4 both sides, and we get y equals 8. Now we can check that using this equation here. So 5 times 5 is 25, take away 4 times 8, which is 32, is minus 7. So we know we've got it right. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these three here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600, take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here. And this will be 1,600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi. And that indeed is our answer. You can't simplify that any further. So we've got to get the left-hand side factorised. So we put down 2 sets of brackets. And we're looking for 2 numbers that multiply together to make that 24 and add together to make the 14, and we're going to have an x at the start of each of those brackets. So 24 would be 12 and 2 would add together to make 14, so plus 12 plus 2. And to solve, we get the left hand bracket equal to 0, and we get our solving lines in. So minus 12 both sides, and you get x equals minus 12. So that's one of our solutions. And we do exactly the same thing with the other bracket, get it equal to 0, and solve. So we're going to take away 2 from both sides to get x on its own, so x equals minus 2. So our solutions are 12 and minus 2. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. When solving simultaneous equations graphically, if you draw the lines to both graphs, which we have done here, the solutions, or solution, because they're both linear, will just be where the two graphs cross. So this here will be our solution. So x is 2 and y is minus 4. In this question we have a right angle triangle and we know 2 of the sides and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12 and the 13 we've just found. When you do that you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. So here we're asked for a minus b. So in our vector we're going to do a, which at the top is 5, take away b, which at the top is 4. And we're going to do the same with the bottom. So we're going to take away the minus 2, take away the 7. 5 take away 4 is going to be 1. Minus 2 minus 7 is going to be minus 9. So our vector will be 1 at the top and minus 9 at the bottom. We know that vectors are written as the amount right at the top and the amount up we go at the bottom. So looking just at the x coordinates, we've gone from 5 to 7, so we've gone right 2. Looking at the y coordinates, we've gone from 6 down to 2, so we've actually gone down 4, so it's going to be minus 4. We're going to start by just drawing the line y equals minus 2. So the line y equals minus 2 will be a horizontal line at minus 2, which will be down here. Next we're going to do the line x equals -1, and that will be a vertical line at -1. Now here's a bit of a problem. We've got no equal to underneath it, and whenever we don't have an equal to, we do a dash line. So we're going to do a dash line here. Okay, the last graph is a little bit harder. We've got I'm going to do y equals x minus 3, and it's going to be a perfectly diagonal line, but down to -3. So it's going to be this line here, about there, but it's going to be dashed because we don't have an equal to. So it's going to be a dashed line like that. So if they have an equal to underneath, then it will be a solid line. If they don't have an equal to underneath, it will be a dashed line. Okay, now we've got to work out where the region is. So we've drawn the lines, and the lines are either dashed or solid, and so they're perfect, but we've got to work out where the region is. So we can see on the first one that y is greater than or equal to -2. So it's going to be above this line. Okay. You can see on the next one that x is greater than -1, so it's going to be this side. So we've already narrowed it down to somewhere in this region here. And here we're given that y is greater than x minus 3. So what we do here is we pick a point. So I'm going to pick a coordinate, and I'm going to pick 0, 0. 0, 0 is always my go-to one. Write out the equation, and I'm just going to put a box here, so x minus 3, and fill in the coordinates for 0, 0. So 0, blank, 0 minus 3, 0, blank, 0 take away 3 is -3. So what is 0 compared to -3? Well, 0 is greater than -3. And therefore, this coordinate is on the correct side, because if we look, we've got y is greater than x minus 3 is our region that we're looking for. So we're looking for that, that's good. And so our region will be anywhere in this bit here. Anywhere at all. And you're asked normally to mark it with an R. I'm kind of colouring it in just because your R can be anywhere within this region. It can actually be at 0, 0. Anywhere within the yellow region would give you the mark. So the first thing we need to do is factorise the quadratic. And to do that, we first of all multiply the coefficient of the x squared and the number on its own at the end together. So 3 times 22, which would be 66. So we're looking for two numbers that times together to make that 66. And we look at the coefficient of the x, which is 35, and we're looking for the same two numbers to add together to make 35. So they're both positive, so we're going to definitely have positive numbers that we're looking for. And just thinking it through, 2 times 33 looks like a good candidate. Let's just check that. And you can just write down the factors of 66 if you're not quite sure. And 2 times 33 is 66, 2 plus 33 is 35. So we know we've got the right ones. So I'm going to rewrite the question. But instead of the plus 35x, I'm going to write plus 2x plus 33x. So we've got 3x squared plus 2x plus 33x and then plus 22. I'm going to leave it as an expression. We'll worry about the equation at the end. And I'm going to look at just the first two terms, and I'm going to look at the second two terms separately, because we're going to factorise them linearly. So this first one, we're just going to factorise. So that would be 3x plus 2. And the second one is going to be 11. And it's going to be 3x plus 2. The repeating bracket is one of our brackets. And the bit left over, the x plus the 11, is our other bracket. Cool, so we've got x plus 11, 3x plus 2. So we solve each of the brackets, get them both equal to 0. And let's get our lines in. Minus 11 both sides. We've got x equals minus 11, and that's our first solution. And then do exactly the same thing to the other bracket, get it equal to 0. Our lines in. So we're going to take away the 2 first of all. So we're left with 3x equals minus 2. And then we're going to divide by the 3. And a way we can show that is with a fraction. So it becomes minus 2 over 3, or minus 2/3. The first thing to notice is we actually have 2 radii here. So we've got this radius here and this radius here. And all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well. And we've got to write that down. So we're going to say angle OBA is equal to 19x. And the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here, and all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180, and let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now, there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees, because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, it's just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. You're expected to be able to draw a sine, cosine and tangent wave, and here we're asked to work out what y equals cos x looks like on a graph. Now cos x starts at 1, goes down to 0, then goes down to minus 1 at 180, then back up to 0 at 270, then back up to 1 at 360. But don't just join it up with straight lines. That will not get you any marks. You've got to make it look like a wave. And this is not the easiest thing to do, but they are very forgiving over how you do this. As long as it goes through the points, and as long as this bottom bit is a U shape and not a V shape, then normally you will get the mark. So although that doesn't look perfect, that would definitely get the marks. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. First thing I notice is that this root 125 can be simplified. So root 125 is just root 25 times root 5, which is 5 root 5. So if we write this out, 47 over root 5 plus 15 over 5 root 5. Something else we notice is we can actually simplify the second fraction. So divide top and bottom by 5, so we're left with 3. Now here, because we've got the same denominators, we can just add these. So 47 plus 3, which is 50. And notice the a root 5 isn't in a fraction, so we're going to have to rationalise the denominators, which means we're going to times top and bottom by the surd at the bottom. And so we end up with 50 root 5 over 5. And we can actually simplify this to divide top and bottom by 5, so we end up with 10, and it's all over 1. So A is therefore 10. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is. And that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern. So the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x. And so it would be 847.4747, etc., etc. Next, I'm going to take away everything. So 1000x take away 10x, and that's going to be 990x. And then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. So for this question, first thing to notice is there's a divide there, and we can actually just write this as a fraction. So 10 plus root 2 over 14 plus root 2. I'm going to keep the brackets there. We don't need them when it's in a fraction, but it will help us for the next step. So we're asked to transport this or change this into a fraction without a surd at the bottom. And so it's basically asking us to rationalise the denominator. Now, when you have two terms, including a surd at the bottom, we need to do something a bit special with this. And the thing we do is we times it by the opposite bracket. And what I mean by that is if it's 14 plus root 2, we times it by 14 minus root 2. And we've got to do the same to the top. And the reason for that is essentially here all we're doing is we're timesing it by 1, because 14 minus root 2 over 14 minus root 2 is just 1. So we're timesing it by 1, so we're not changing the fraction at all. Okay, let's draw a grid to work out what that will equal. And you can use any method you want. You can use double smiles and rainbows, FOIL, whatever method you have to multiply two sets of brackets. I'm going to start off with the top. The top is 10 plus root 2 times 14 minus root 2. So 14 times 10 is 140. 14 times root 2 is just 14 root 2. 10 times minus root 2 is minus 10 root 2. And then a minus and a positive make a minus, and root 2 times root 2 is just 2. Now, when you expand surdy brackets, these two and these two will add together. Okay, so we're going to start off with the numbers. 140 take away 2 is 138. And then we'll do the surd. So 14 root 2 take away 10 root 2 is plus 4 root 2. Okay, so the top is going to be 138 plus 4 root 2. And let's do the bottom. And I like these grids because you can see if you've made any mistakes quite quickly with these. You can check your working. So 14 plus root 2 times 14 minus root 2. And you'll see why in a second we do the opposite. So 14 times 14 is 196. 14 root 2 minus 14 root 2 and then minus 2. So you can see here now there's a 14 root 2 plus minus a 14 root 2. Let's just cancel each other out to 0. So we get rid of the surd. And then 196 take away 2, which is 194. So we've got 194 at the bottom. Now something we notice here is that all the terms in the fraction are even. Therefore we can halve everything. So 138 halved is 69. 4 root 2 halved is 2 root 2. And 194 halved is 97. And so that would be 69 there, and that would be 2, and then that would be 97. So we're going to just quickly write out our sequence, so 9, 22, 41, 66, and 97. And we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19. So they're different already, we know that it's not a linear sequence. And that's going to be plus 31. So we now look at the difference of the differences. And so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence. And we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it. And it gives us 3. Now that 3 is actually really important because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth, and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66, and 97. Now, we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3. 3 times 2 squared, which will be 12. And then 3 times 3 squared, 27. 3 times 4 squared, 48. 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now, what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. Here we've got a half on the outside, so our function's been multiplied by half, and all that's going to do is it's going to halve each of the y coordinates. So we've got a y coordinate here, and half of 6 will be 3. The 3 we've got here will be 1.5. The bottom of the curve here will be at 1. And you just go through and just halve all of the points on the graph. And when you do that, you should be able to draw in the graph, and it should look something like this. We'll try our best to draw it. And we're not looking for it to be absolutely perfect, but looking at that, you can clearly see that all of the y coordinates have been halved. When you have a minus in the brackets in the function, you're going to reflect it in the y-axis. So we're going to have to reflect this in the y-axis. So we need some kind of understanding of what the sine wave does before it gets to 0, 0. And it starts by going up. So when we go backwards, it actually goes to -1 at 90. And then it will go back up, or at -90 I should say, then go back up to 0 at -180. So what our graph is going to do, because it's reflecting in the y-axis, our graph is going to go down to 90. Go down to -1 at 90. Now a sine graph normally goes up, but this is going to go down. And actually it's going to look very similar to if it had reflected in the x-axis, but that is not what's happened. It has reflected in the y-axis. It just happens to be identical to if it had reflected in the x-axis. So it's going to go down to -1 at 90. Back up to 0 at 180, and then just keep going with its cycle. That's not great. We need to cross the coordinates, but as always, make sure you have nice, smooth U shapes at the bottoms and the tops, and that's more than good enough to get the marks. A simple trick when you're finding the inverse of a function is to replace or to switch the y and the x. Now we don't actually have a y in here, but we can just put one in. It's not a problem. So we can just rewrite this function as y equals x over 10 minus 11. And we're just going to switch around the y and the x. So x equals y over 10 minus 11. Now the objective now is to get the y on its own, to make y the subject. So we're going to first of all add the 11 both sides, and I've made an amateur move here. I've not left myself enough room, so let's just scoot that across. Okay, so add the 11, so it would be x plus 11 equals y over 10. Next thing we're going to do is multiply by the 10 to get y on its own. So it would be 10 brackets x plus 11 equals y. Expand those would be 10x plus 110 equals y. Now this doesn't equal y. We are looking for the inverse function with this notation here. So we just replace the y with this notation, and we get 10x plus 110. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.